I'm K. Ashish, studying second year in AC department of third sem. My tech talk topic of data structure subject is graph analytics accelerators for cognitive systems. Introduction to graph analytics. Graph analytics is subfield of data analytics focused on the study of graph structures. It is essential for understanding relationships and connections in complex data. Cognitive systems leverage graph analytics to enhance decision making and learning capabilities. Cognitive systems consist of mainly such as natural language processing, artificial intelligence, machine learning, and data analytics. These are the systems which rely on the processing large amount of data. Hence, there are ongoing efforts to integrate big data analytics with cognitive systems. Graph analytics has been gaining popularity recently, especially due to the abundance of data from the web and social networks. Specifically, graph-based knowledge bases can be used by cognitive systems for reasoning and human interactions. This is the introduction of graph analytics. Now moving on to next slide, we have cognitive systems overview. The overview of cognitive systems, human thought processes to analyze and interpret information. They utilize various technologies such as machine learning, natural language processing, and computer vision. The integration of graph analytics allows them to process intertwined relations more efficiently. Here we have cognitive computing and artificial computing. Machine learning, natural language processing, neural networks, deep learning, sentiment analysis stimulate human thought process to assist human in find solution to complex problems. Customer service, healthcare, industrial sector, which can be seen in cognitive computing, whereas artificial intelligence, which have machine learning, natural language processing, neural networks, and deep learning. Finding patterns in big data to learn and either reveal hidden information, deliver solution to complex problems. Automated processes can be seen in artificial intelligence. This is the overview of cognitive systems. Next, moving on to next slide. Now we will know about the importance of graph structures. Graph structures represent data in nodes and edges illustrating relationships clearly. They enable the modeling of complex interactions such as social networks or biological systems. Understanding these structures is crucial for accurate data analysis and insight generation. Key features of graph analytics. Graph analytics tools excel at handling large complex datasets with interconnected elements. They provide capabilities for pattern recognition, anomaly detection, and community detection. These features are vital for cognitive systems to derive meaningful insights from diverse data sources. Here we can see the data analytics at American Institute for Research, enterprise analytics solutions, social media and digital outreach, their services and the collection, data quality and the access to it and the improvement take place, data integration and visualization. Now here in this slide we have about graph analytics accelerators. Accelerators enhance the performance of graph analytics by leveraging specialized hardware and software. They can be optimized algorithms for speed and efficiency, enabling real-time data processing. The use of accelerators is essential for applications requiring rapid decision making in cognitive systems. Many graph algorithms are iterative in nature, where execution and continues until a convergence criteria is met. However, the number of iterations required to converge the individual vertices can be vary significantly. For instance, plots the percent of vertices not covered through the PageRank iterations, where only less than 1% of vertices require two iterations to converge, while single instruction multiple data SIMD type of architectures can process multiple vertices simultaneously. Now, applications in cognitive systems. Graph analytics accelerators are used in fraud detection within financial services. These are instrumental in recommendation systems to analyze user preferences and behaviors. Healthcare applications leverage graph analytics to uncover insights from patient data and treatment outcomes. Benefits of machine learning in fraud detection: easy scalable, better classification, cost effective, better protection, and also increased accuracy, faster, efficient. Now, challenges in graph analytics. Large scale graph presents challenges such as processing speed, storage, and requirements. Ensuring data quality and accuracy is critical for reliable analytic outcomes. Interpreting results and deriving actionable insights can be complex due to data's interconnected nature. Applications and challenges in large-scale graph analysis. Graph analytics based on cognitive applications are different than traditional compute-intensive applications. With regular access, patterns and abundant data and thread-level parallelism as well as we discussed later, graph applications are hard to parallelize due to their irregular execution patterns and synchronization requirements. In this purpose, an accelerator architecture that is specially targeted at graph analytics applications. The process architecture is implemented as a template through to make modeling different application easy. Architects and designer can plug application level different structures and functions into this template to generate hardware and implements for a large class of graph analytics applications. Now, future trends in graph analytics. The integration of AI and machine learning will further enhance graph analytics capabilities. Advance in quantum computing may revolutionize the way graph problems are solved. Increased focus on privacy and security will shape the development of graph analytics tools and techniques. The need for better security and extended adoption of predictive analysis. These are the top big data trends: more cloud adoption, more data sources, flexible and customizable dashboard, the rise of machine learning, more advanced big data tools. Here we can see the future trends which can be seen in graph analytics. Now moving on, we have case studies of success. Major tech companies have successfully implemented graph analytics to optimize user experience. Financial institutes use graph analytics to detect and prevent fraudulent activities effectively. Healthcare providers have improved patient outcomes by analyzing complex relationships in medical data. However, the core algorithms in cognitive systems implementing these applications on existing systems efficiently is not a trivial task due to several reasons such as memory access, bottlenecks, synchronization problems, and irregular computation or communication patterns. This can be seen in the case studies of success of cognitive systems algorithms. The active list stores the set of vertices that need to be executed in future. The initial AL is application dependent and the system memory. As explained before, the application specific converge condition is checked in SCU to determine which vertices to schedule for future execution, while the unnecessary activations are filtered. And in SYU, the active list manager is responsible for the following tasks: extract vertices from AL and send them to runtime for execution, receive new activation requests from SYU and add them to AL while avoiding the duplications. For storage and data efficiency, the AL consists of two data structures: a bit vector where each bit corresponds to the presence or absence of a vertex in AL, a queue of bit vector indices where each index corresponds to a 256-bit segment of the bit vector. For the purpose of extracting new vertices for execution, the ALM the bit vector from index from the AL queue and loads the corresponding 256-bit segment of the bit vector. So it is simply said that bit locally, otherwise it's sent to the request to the AL memory unit, specially needs to be taken, handle in-flight vectors and vertex indices. The runtime module is in charge of monitoring available resources in AU and scheduling no new vertex executions. It reads the new vertices from ALM and sends them to SYU, where it detects and their available resources. It is responsible for detection, termination, condition, and sending out them signal where there is no in-flight or execution vertices that kept empty in AL. So this is about the conclusion of graph analytics in cognitive systems. The main points are graph analytics accelerators play a crucial role in enhancing cognitive systems where they can be analyzing organizations to higher harness the full potential of their data through advanced insights. Thank you.